Hi, in this video I'll show you how to make the first part in lab 3 for the project parts, the sliding block. So we have 3 parts in lab 3 for the project, and those 3 parts are the jaw and the sliding block, and this one, a knob. Okay, so let's start with the uh, sliding block. Okay, so let's have a new file. Okay, again that should be in inch. Okay, so I'll just save to anywhere. Then this one is very simple, just a single extrude. The only thing is the sketch. Okay, so we'll zoom in on the sketch. So basically it's a couple gears or couple teeth, and the bottom of the teeth are tangent to this diagonal line. Alright, so we start with the overall rectangle, so 0.625 by 0.25. So I just start from here, from the origin, and the width 25. Hit enter, then the height is 0.625. Okay, and when I'm done, I can choose which side I want to put my sketch. Okay. Now, next we can have a rectangle as a diagonal for the rectangle. And turn reference. Okay. Then we'll start from those the lines that crossing the diagonal. So we can start from profile tool from the top. And I don't really care what the angle is or what the dimension is, as long as this they're connected from this point to this point to this point, but at bottom it's separate, so we'll just stop there and we'll stop here. Okay, so here I'm gonna press my mouse button or the wheel. You can hit the wheel, then it'll stop this profile tool. Now we'll continue for the next couple lines. If you come into any position that you'll see a parallel and you don't want it because they are not parallel, and somehow it's close to that position, the software will try to give you that constraint. You can just hold Alt key and it will disable that function. Okay, so but also it will disable the auto constraint, so probably that's not a good idea. I'll just select those 2 points. Then in this pop-up menu I can make them coincident. Alright, then we don't have to turn them into reference because we're going to use this line later on. Then we'll just give them dimensions. So I'm using shortcuts, the keyboard shortcuts for dimension. That's D, so you can press D. That's why you don't see me click on that on the icon. So 45 degree for this, then this is 50. Yeah, here it's 54, and the corner is 45. Okay, then the bottom here, I guess we don't have any angle dimension left. Then we'll start from the bottom. So the next is this point to the bottom. That is 0.17. And you can see the whole thing is green, so they are all constrained. Okay. Just tune my mic. Okay. Then those corners are fillets. Okay, then the top corner might be a little bit harder to use a fillet. So you can just get a random circle, and I think it's not giving me the tangent constraint, so it doesn't matter. We can pick the circle and pick the top line, make them tangent. Pick this circle and pick the vertical line, make them tangent. Then I have this radius, so I'll hit D for dimension. So it's diameter now, so I can just say I think it's 0.15 in diameter. Alright, so that it's the same size as this arc, and here it's, as it said, the bottom is tangent to the diagonal line. So we can probably just use a fillet. Okay, and I don't know the dimension for this, but I know it's tangent, so I just make sure this line is tangent on the diagonal. Okay, as you can see, that's the tangent constraint. Now here we do have a radius for that, 0.01. Okay, actually I should take care of the bottom arcs first, so we'll just do this and make a tangent here, then make another fillet tangent. Even though it doesn't look like they're intersecting on a single point, that's once you click, it'll make sure this is tangent. Okay, then for those fillets with radius, we can type in the radius first, then hit enter. So 0.2, I have 3 0.2s. This one. So here you can't click the corner, because the corner point, you have 3 lines coming into a single point, one corner. So unless you know which corner you're picking up, it's better just click 2 lines. Then we have 0.2 in the middle. So you have 4 corners, you can make the fillet. And the bottom one is 0.01, so I change the radius. 0.01, then we made this already. So we have the geometry. Next, I can trim the lines off, clean this up. Okay, if you want to, you can clean this up. Then the vertical lines, I probably need this because all the points are on this line. So what I would do is just turn that to reference. Okay, and it's a little bit messy. You can move things around. So I'm not going to do that here. That's my sketch. Then extrude. In case you didn't trim this clean, you can use region boundary curve. Then pick the area. Then the extrude distance is a 1/4 inch. So this is symmetric. I'll do a symmetric extrude, then the distance will be a half of the total distance. Right, so that's for the sliding block. Then we can choose the this locking knob. Okay, so the locking knob is I'll just take a picture, show you the picture here. Okay, so this one is on the top of the pliers. If you switch the position of this knob, it'll lock the pliers. Okay, so nothing fancy. It's just the sketch is a little bit hard, and you don't have to do the teeth. We gave the dimensions, and I'll show you a little bit in the video, but you don't have to. Okay. So couple ways to do it. You can extrude this shape, the section AA, then cut from the top and the bottom into, cut a little bit into this, then make another 2 cylinders and drill the hole. So that's what I'm going to do. Alright, then we can get rid of this. I can get rid of this one. You should probably save that. And again, XY plane. Okay, you don't have to pick if you want to. Then we'll start from this sketch here. Okay. So basically, we're going to extrude this shape first. And this is a little bit complicated. Then we'll start from the circle in the middle, the biggest circle, which is diameter 5/16. So 5 divided by 16. Then it comes tangent 2 lines, tangent into where? Let's see where. Well, we can start from the rightmost circle, which is radius 3/8. So I'll just make a whole circle, then that'll be 3/4 in diameter. Then we have the line goes a corner at this arc, so that's 5/16 in radius, which is 5/8 in diameter. So rightmost, right second comes in. There's intersection between them, so we don't need any circles between them. I think we're good now. Alright, now we have a line from here, which is tangent, goes in, and there's intersection point, which this line intersects with this line. Okay, and that goes up, then this goes to the outmost circle. Okay, and you can do a mirror or just do like this. Then we'll add some dimensions. Okay, all right, so that's the general shape. Then we have this 30 degrees, so we'll add a 30 degree. And of course you want this to be symmetric, right? Let's see what we can do. Okay, so those two, they intersect at a point that's not on the origin. Okay, that's 30 seconds away from it. So probably I should make them intersect first, and that's the point. I used the this tool called Make Corner. Then this point should be on x-axis, so that's a geometric constraint point on curve. I'll select this point and constrain to the horizontal axis. Okay, as you can see, we have this here, and now we can give dimensions from the y-axis to this point. Is 3/32. Then the angle is 100 degrees between those two lines. Okay, so that's 100. And again, you notice this is not symmetric because the top and the bottom, those two lines are not equal. So we can click those and give them equal constraints. Okay. So these two lines are still not constrained. You can try to move it to see what happens and why. The reason being is those two are not centered, but we can move them later. Okay, and these two 50 degrees we have. Okay, so let's make these two equal. And make these two 50 degrees. Actually, it might be easier just add a vertical reference line and make it a center point. So if we have this vertical reference line, construction line, and everything should be constrained, because this one will center the triangle here. Okay, then we do have a fillet between those two lines. So fillets, where's the radius? Let's see if we have it here or on the top. Okay, if we don't have it, just let me try it. Maybe 0.05. Yeah, okay. 0.05. I'll head back to the slides. Alright, so I just checked the model. That was 1/16. So it's a little bit bigger than what we have now. So 1/16 for the fillet. And at this point, you can probably, let's see if everything's fully constrained. Needs one constraint and turn on dimension, see what happens. The reason being is once we do the fillet, that will take out the equal length for those two lines. So we'll just select the both, make them equal. It should be fully constrained. And by the way, you don't have to do this. So once that's done, we can trim this off. Don't really need those. If you don't like the diameter dimension, you can change that to radius dimension. Yeah, it'll say over constraint, but you can delete the others later. Okay, then you can delete those two diameters. So it will have something like this. And I think we're good for extrude. Okay, so finish the sketch. Then we'll extrude into the highest height, 3/8 extrude, and this is a region boundary curve. So I have to pick all three regions, symmetric, and half of the total height, 3/16. All right, now then we will make this arc, the 3/16 arc, and cut it from the top and the bottom. Now here we need another sketch on XY plane. You don't have to select, just say OK, then that'll give you this. And for this one, you don't have to draw a half or the partial arc. You can just make a whole circle and at radius of 3/16. So the diameter is 3/8, and that'll be enough for the extrude or for this sketch to cut. Okay, so we'll select this circle, and how much we need to cut is from here. The middle is 3/16. So what we do is, for the start or for the end, we can let it extrude as long as you want. it doesn't matter. It's the bottom or the starting point. Should be 3/32. So the bottom is 3/32 away from the sketch. So if we do the same thing for the other side, that will give us 3/16. And here the Boolean operation, you want to use a subtract. Okay, so let's see what happens if we do apply. That'll cut this. Then we select the same thing. And we have all the distance figured out. We can just simply reverse the direction. And still on the subject. And that's the cut. Then we'll build these 2 cylinders. Okay, again, that's another sketch. And that's again on the XY plane. If you feel it's too much on the same plane, you can hide other sketches. Okay, so this time we have 2 cylinders. I can put them in the same sketch, or if you like, you can put them separately for if you want to manage them in different sketches. So 5/32 and 9/32. Okay, and a finished sketch. The larger cylinder is symmetric. The smaller one is the same as the part we made last week. It's not symmetric. So we'll just start with the smaller one first. So I just changed it to a static wireframe. You can see anything inside the solid. You can also hide the extrude. And here, if you select the region boundary curve, it'll just extrude this tube shape. So if you want to extrude the bigger cylinder, you have to select both regions. And it's a symmetric total distance, 1/4 inch. So that'll be 1/8. And be careful here, the Boolean is still on subtract. I'll turn this back to smart. Invert and apply. Then you can take a look. Okay. Then we'll do the second one. So here, come back to the smaller circle and the distance. So we'll start from the top is 1/8 plus 1/32, and the bottom is minus 1/8 minus 1/16, and also unite. Okay, and you can take a look. Once we say OK, that's the geometry. Then next we have a chamfer. Okay, a chamfer 164. It's a symmetric 45 degrees, so 1/64. If you don't hit enter and you click that, it'll give you an alarm because that one is too big. It's not 1/64. It was still 1 inch. So you have to hit enter to make this goes into the system. So apply, and we have another chamfer. I don't know if I have it here. 3/64, this one, and then we also have another 1/64 at this corner. So we'll do the big one first. Usually, the edge blend, fillets, and the chamfer, you want to start with the larger radius or distance first. So this is 3/64 for this arc, top and bottom. Apply. Now we have a 1/64 for the sharp corner here. Okay, so at this stage, it's good for submission. It's good for your midterm report. Okay, and if you don't want to do the teeth, you can close this video. Well, also you have to make this whole. It's pretty easy. The only thing might be it's the first time we draw something on another plane, not other than XY. So you want to select YZ plane, which is vertical. You have to. It might be hard to select a plane at first. The trick is zoom out, make the data in the middle become bigger than the part. Then you can click on this corner. Okay. So here's my orientation. The data is circle is 1/8. Then we can just go straight to extrude. Because this is a subject, you can take a look which direction you want to. So 1 is definitely 0, as that's on the sketch origin. The other one could be big, and we'll reverse the direction and make it subject. So it doesn't matter how long you extrude, as long as this is longer than your part, then it'll make a hole in the middle. Alright, now that's the some. It's time for some extra. So this is the teeth, and we'll count how many. Okay, this is 1 indent here. So 1 cut, 2, 3, 4. So 4 cuts, and you want to make sure each copy is the same, right? So you need to find the repetitive pattern. So from here stops at this dimension line. That's one repetitive feature. And then when we come to lower end, that's another cycle. So we need to draw something like this, then do a pattern. So we can start another sketch. Now this time on XY plane, so you don't have to select. And we can hide the solid. We can also hide the last sketch. We just need the first sketch. Okay, and we need to make the teeth based on this line. So we just need one line. Actually, we can extract that line from the first sketch. It's called the project curve. Okay, so we'll project that curve into the present curve. And you have to change this filter to single curve because we don't want everything from that sketch. So just pick this sketch and say OK. You will notice the color is different. After I hide the first sketch, this line is in the sketch I'm working on now. So that'll be the outside line of this teeth. Then the spacing between the top and the bottom of the teeth are 1/64. So that sounds like an offset. Okay, so 1/64. Hit it. Then it goes inward, which is good. Then we'll just draw some shape here. We can draw something like this. And it'll snap to the center of the arc a lot of times. So you can turn this off. And it is snapped to a weird spot. Okay. You keep doing that. Let's see what we can do. Alright, it's keeping snapping to that spot. I'll use a straight line instead. Let's see what happens. Yeah, I want to be tangent. I don't want tangent. So maybe start from the outside. Okay, so that's pretty much what we need, and we can draw a construction line for this. Okay, so as you notice, it's auto give me the tangent constraint. I don't want that, so I want this point to stay with this point. They should be coincident, and this is vertical. So select the vertical line, which is not vertical yet. Now it's vertical. Okay, and at the top, I'll just drag this point. Okay, oh, that's a reverse. So all right, now first we need to center this. That's the cut in the right in the middle. So we can use a midpoint constraint for this line to sketch origin or the center of the arc. It's the same thing. Midpoint. Okay. Then because those two lines should be symmetric, so they should be equal. I'm gonna turn on the dimension. Take a look how much the degree of freedom we have now. Then we'll give this line a dimensions 1/32, and also turn to reference. Then 30 degrees. I think, yeah, after 30 degrees, those two lines are constrained. Then the top, we have a dimension for that. Yeah, I have dimension for 1/64. So as you notice, this is not the vertical distance. Okay, so you might need to specify that's a parallel distance, because if you just use the inferred distance between these 2 points, it will be very easy to become a vertical distance. So there is a position you can make it into a parallel distance, and that is 1/64. Okay, now you notice the angle is different. So we can make them equal as well. So let's see, this is fully constrained, and that's the pattern we need. And actually what we need is just the cut. Okay, so that is one repetitive feature, and I want to know if I do a circular pattern, how much the angle is, so I can, how big this the span or the pitch. So I can draw 2 lines to make I should draw at the bottom. So from here, the center, because this point is actually, that's the starting point, that's the ending point. That line is another circle, another cycle. So turn them to reference, and I tried to use a pattern in the sketch, but seems like in this tool, the pitch here, you can't measure the angle inside a sketch. So if you can figure that out, you'll be more than welcome to tell me that. And what I did is I did that in a pattern feature in the 3D. So to make a cut here, you need the closed list loop. I'll just simply draw a box. Okay, if you want to constrain this, you can constrain this line. Okay, so I'll use this. Let's extrude first. We'll extrude that volume, that area, and make it intersect, subtract from the big one. So it's -1. Now you can do a symmetric. So that is one cut. Then we can pattern this feature, this extrude. So we have this pattern tool. That is pattern feature. This is pattern curve. So feature, extrude, sketch, those things. All right, circular pattern, and this is in 3D, so the center is a little bit different. The vector is z-axis, point is the origin. Okay. Then pitch and let's see, we can say count and the pitch. The pitch angle is the angle between those two lines, right? So you notice we have this little arrow here. If you drop this down, we have this measure tool. You don't have to know exactly what angle that is. You can change this to vector, between vector and vector. So we'll pick this line first. Then second vector is this line. So that's the angle of a single repetitive unit. And it's still not doing work. Cancel this. Measure again. Okay. I don't know why, but sometimes NX it's maybe a bug. So two objects. Oh, that was on vector. So two objects. That's the angle between them. Say OK. So it'll just transfer the measurement into this pitch. Okay, and feature. Okay, select the feature. We want to select this feature and extrude. And you can see from the top. Okay, so we have 1, 2, 3, 4, 5. We say 5, and we can click preview here. Looks good. Just apply. Now for the second, the other direction. Okay, we'll pattern the same feature. Still z-axis. You can also select from this menu. Z-axis, the point is origin, so we have this point dialog, 3 zeros, and the same angle. The difference is we can flip the direction. So that's actually on the vector, because you know, right hand, left hand. If you change the direction of your vector, it'll change the angle, the direction. So as you can see, we have 1 going out of the solid. If you do 5, it'll probably complain. Right. So it's complaining outside the screen. It's here. And that is because we have 1 cut out of nowhere. So we can do 4 counts, and the measurement again between these two lines, and the 4 counts. That should be okay. And actually we need to cut 1 more. Out of 5. Then that's for the teeth. Okay, so this is the end of this video, and we have another video for the last part, the jaw, which is this thing here.